Hi friends, good morning to all of you. Welcome to Ram's Academy. My dear viewers, today I am going to have a class on the topic, important topic called AC voltage stabilizers. Let me discuss about the necessity for voltage stabilizer. In India, lot of equipments are being used by people like television, fridge, and AC, air conditioner, like that lot of equipments people are using. But unfortunately, the voltage to be used for these gadgets, these equipments are 220 volts. It may vary plus or minus 10% voltage only. In the condition, these equipments need minimum most voltage is 200 and maximum voltage 240. When that is the case, what happened is, if the incoming domestic power supply is not able to provide the voltage between 200 and 240, the equipment's performance will deteriorate. If the voltage is going high, that may be spoiled. If the voltage is going down, it may not get spoiled, but it may show a poor performance. Like that, Indian condition is when the input domestic power supply is changing, the performance is dependent on that. Therefore, something has to be done. In some of the cases, we have seen that in villages and other places, in an area where industrially heavily populated, in their condition, the voltage is not going to be constant. Sometimes they are going down from 200 volts also. Sometimes where there is a village where there nothing, the loading is not that much, incoming voltage, substation may be very near to that. In their condition, the voltage may be going up. The voltage may be even 270 volt. The people who have designed refrigerator, air conditioner, or the television set, or audio amplifiers, all these things, when they are requiring a voltage between 200 and 240, that is 220 plus or minus 10%. Specification for these equipments is only 220 volts plus or minus 10%. When that is there, if the voltage, actual voltage coming to the domestic power supply is less than 200 or going beyond 240, according to the thickly populated area or an industrial area or a place where it is near to substation, like that, voltage will be definitely different. They are not able to meet the specification of the equipments. The performance is going to vary. Otherwise, equipments may not give sufficient lifetime. Therefore, we have to do something. What is that we can do? We have to put an equipment which will be able to adjust what is going on in the power supply variation, and accordingly it should provide specified voltage for these equipments. Therefore, the necessity for providing a stabilizer is there. Without that, that will be definitely spoiling the equipments. Therefore, we have to design. There are a lot of companies in India. Lot of companies are there. They are manufacturing voltage stabilizers for these equipments. There are a lot of equipments. Everything is having a different power also. AC power may be different. In their condition, there should be a regulator, not only the looking after the voltage, but according to the power, the voltage stabilizer should be designed. Many manufacturers are there, but for the students who are learning, they should know about it. What is that inside? How they are designing? All these things they have to learn. Therefore, we are coming out with a video. What is there inside a stabilizer? How they are being designed? What is the expectation of a voltage stabilizer? All these things, let us discuss about it. Let us go to the actual discussion. Let me discuss now the stabilizer. As I said, it needs stabilizer. It is a stabilizer which should accept 220 volts plus or minus 10%, and then it's an equipment which needs only 200 to 240 only. Instead of, we think inside a home the voltage is supposed to be only this, but sometimes it is not. Actually it is going to be 220 plus or minus even 25%. This can be accepted. This cannot be accepted. Now this comes down by plus or minus 25%, means 50 volts down, 170 volt. 170 volt to 50 volts extra, 270 volt. If this is a voltage we feed to the equipment straight away, what will happen? Equipment will burn. Lot of failures will happen. Performance is not going to be constant. Performance will vary. Therefore, we have to design this to accept these variations and give out this only which can be accepted by equipment. Therefore, stabilizers are doing only that purpose. Let us move on to that. How they are done. How we are able to, when the input voltage is going up, what is that we do inside the stabilizer? When the input voltage is coming down, what is that the voltage stabilizer does? All these things I am going to discuss now. For that, a basic understanding is necessary. Let me move on to another electrical technology in which an important component, that is a transformer, how it is working. If you have understood the functioning of a transformer, then only you can modify slightly the transformer, accordingly a voltage stabilizer can be built. Therefore, let me move on to a transformer, how that is functioning, how we can modify according to our necessity. All these things I will discuss. A transformer AC, transformer is always going to work on AC only. No transformer will work on DC, direct current. There has to be an alternating current. There has to be a electromagnetic flux. Amplitude should be changing. Direction of flux also should change. Like that, then only a transformer will work. A transformer contains a primary as well as a secondary. So in between, if you draw a straight line like this is the core type of transformer. Inside there are laminations. Silicon laminations are going to be there between the inductors L1 and L2. That is what these lines are mentioning about. This is going to be the primary, that is 220 volts or something AC, and you have a secondary. The secondary voltage can be decided according to the number of turns and other things. Therefore, let us understand that though I have drawn the equal number of lines, it doesn't mean that this is equal to this. No, it's small for expression, for to understanding. Understanding, I have drawn more number of turns. The secondary also, but this is going to give only 30 volts. It is going to give 30 volts only. This is an alternating power supply. This is also an alternating 30 volts. Now let us understand that this is going to be neutral. This is going to be the phase. When we are applying this voltage to the primary, secondary voltage will be 30 volts. If we ground this, this is going to have an alternating voltage like this. When it has a positive cycle, this will also have a positive cycle. Therefore, with respect to this will change from 0 to 30 and to minus 30, like that it is going on alternating. But with respect to this is going to change to maximum 220 and then come down to minus 220, like that it is going on alternating for about 50 times per second. This also 50 times per second. But amplitude is large here, amplitude here it is going to be small. Therefore, in electrical technology, there is a possibility that when this potential is increasing and this potential also increasing with respect to this, If I join these 2 points, with respect to this will increase to 220 plus or minus something, and then this is going to be 30 volts, this becomes 220 volt, and as it is producing 30 volt, this becomes, it will reach 250 minus 250. Please understand, in a transformer, this works like an auto transformer. Many students might have learnt about auto transformer. This is a primary. Primary has 220 volts. With respect to a common point, it produces 30 volt. I make an alternative arrangement, like this terminal is being connected to the bottommost one, and then the topmost is taken out. Between A and B, the voltage is 250 volts. With respect to common neutral, this principle we have to understand. Therefore, please understand, by using this transformer, having an input of 220 and having a transformer which is 220/30, I am able to take an output of 250 volts. Okay? This is additional voltage. I am able to add. In another this thing, what I am going to do is